Hi, my name is Alex Williams, founder of the New Stack, and you are listening to the New Stack Analyst Podcast, a show about at-scale application development, deployment, and management. Thanks for joining us. Hey, I just want to give a big thanks to VMware for sponsoring the Pancake Breakfast from Kubecon plus CloudNativeCon in Copenhagen, Denmark. Couldn't have pancakes in a podcast without VMware in Copenhagen. Learn more about the open source story VMware is telling at vmware.com. Looks like we have a full house. Welcome to the New Stack Pancake Breakfast. Thank you so much for joining us. Let's give a big thanks to VMware for sponsoring the pancakes this morning. All right. We love our pancakes at the New Stack. We travel around the world serving pancakes. We love these kinds of things, but the only thing that makes these work is if you guys ask questions, and I swear it won't be that difficult because I think there's lots of questions we all have about what we're going to discuss today, and that specifically is about Spiffy. And so our panelists here are very familiar with the topic. Let me ask a question. Who in the audience is familiar with Spiffy? Okay, let's get a question about who we have here. How many folks are here developers? How many people are in operations? How many people are both? All right, we have a cross-section of the universe we all live in right now, right? Great. So we're going to talk about kind of what Spiffy is, why it fits with Kubernetes, what is the role it plays, and discuss that in the context of the issues that the users are facing every day, especially when you start thinking about identity in these very complex architectures. So what I'd like to do quickly is have the panelists just introduce themselves. We tried to get a cross section of folks who come from the community. So why don't we just start here on the left?
Hi, good morning. My name is Krishna. I'm with VMware, and I do engineering. I've done the vSphere identity stack, and at VMware I also do the Kubernetes engineering. And I manage a little Linux distribution called the Photon OS Linux distribution.
Hi folks, my name's Andrew, recovering software engineer and product manager working on Spiffy.
Hi, my name is Andreas. I'm an architect at QAware, which is an independent software manufacturer in Germany, Munich actually.
Hi, I'm Maya Kaczorowski. I'm a product manager at Google working on container security.
Hi, I'm Tom Petruselli. I'm with Amalgam Insights. I'm an analyst who looks at the development ecosystem.
Excellent. And I just want to also say that Judy is here. She has the tickets, so if you ask a question, she'll give you 5 tickets for the Arduino. Where's the Arduino? All right, we're going to... Yeah, well, I'm just going to show it. There it is. Yeah, so yeah, it's actually here, so you actually get it when you're here. So if you ask a question, you get 5 extra raffle tickets, and that increases your chances of winning. So I'm not going to start with a question of the audience, but I do want to just get a level set here, and discuss. We're here for Kubecon and CloudNativeCon, and the project has grown in so much, right? If you were in Austin, you would see so many more people here than there, and than last year. Comparatively in Berlin, there was I think 1,000 people there. So as we get more users, kind of building on Kubernetes, these new issues are starting to surface, and it's actually raising a lot of questions about what have been the concepts that we've been working with traditionally in IT environments, right? So we've been working with identity in a much different kind of a context than we see now. What is that difference, and how is that servicing kind of the need for new platforms, technologies such as Spiffy?
So I'll take the market point of view, which is that Kubernetes is achieving maturity in the marketplace. It's getting a sort of a general acceptance. If you looked at Kubernetes, say 5 years ago, what you would have heard was, is it stable? What do I do with it? That kind of stuff. Did
Kubernetes even exist 5 years ago?
What?
Did Kubernetes even exist 5 years ago?
Maybe it's not even 5 years. Geez, I mean, I think in 5-year increments, because you get to a certain age and you start to think in 5-year increments, because if you If you don't, then, you know. But anyway, the point is that
If you don't what? If you don't what?
Even just a few years ago.
I want to know.
But even just a few years ago, the concerns were really basic, and now that it is achieving some degree of stability, of maturity, what you are starting to see is the other things all coming in. So look around here today, and what you'll see concerns around networking, you'll see concerns around security, all those things that go into making it enterprise level, enterprise grade technology. And what's really interesting to me is how much of it's already out there, and but how much of it we still have to develop too. That's really where the market is right now. Let's make this mature in an enterprise fashion.
So how does identity change, and how does Spiffy address that identity change? Maybe we could talk to either VMware, about it, kind of your perspective.
Yeah, I mean, could I talk a little bit about the traditional enterprise IT challenges?
Yeah.
I started at VMware, and one of the first things I had to look at was sort of the identity system for vSphere. And the challenges are pretty similar in the sense that every service, every user, or every group is a security principle. And the bottom line is that you have to give some sort of a security identity to any one of these, to all of these entities. Challenges continue. If you have a service and the service has an identity, let's say it's an X509 certificate, banks and financial institutions are always worried about saying every 3 months they have to rotate these certs. This is a key requirement. And if you see your traditional applications, what happens is everybody tends to write their service and they drop their certificate and their private key someplace on the file system. And when you actually go back to them and say, hey, listen, I need to now rotate these certificates, nobody knows how to even find these things. Well, that's always, I don't know if that's been a challenge for people, but in the vSphere world, I've seen a lot of people, a lot of banks, financial institutions, insurance companies suffer from this particular problem. And so how do you fix that? Microsoft in the enterprise gave Active Directory, and that was the Kerberos system that they had. Worked really well for users, and worked really great for users. But when you start talking about services, much harder problem. And when you started talking about X509 certificates, even harder problem. And this is something I believe is where Spiffy right now is coming into play right now. Automating and solving this particular problem is incredibly timely right now. So I'll pause on, Andrew.
Yeah, I might take a stab at actually unifying those two questions.
Maybe you could just help us understand what is Spiffy, how does it break down?
Yeah, sure. So Spiffy is actually, it's a new project, but a very old idea. It goes back to Plan 9 and the factotum security component of Plan 9. It then got picked up at Google as a project called LOAS. And
What was Plan 9?
Plan 9 was an operating system that came out of
Bell Labs.
Bell Labs.
Bell Labs, right?
Yeah.
Right.
And the core idea behind factotum was there would be a local API that any service that needed to establish an identity could call into to retrieve that identity. And the idea behind the API was it would be, from a developer's perspective, just ambiently available. Your workload could just call into it. The workload didn't need any real a priori context of who it was. It didn't need to know if it was running in staging or production. It didn't need to have any secrets or keys embedded inside it. It could just call to the API when it needed to find out who it was, and the API would return its identity in the form of key material and in the form of a string and things like that. And what that had is, for developers building on Plan 9 and later developers building at Google, was you had this kind of dial tone piece of infrastructure that you could call into whenever you needed to establish secure communication to any other system. And it sort of put traditional authentication on its head to a certain extent, rather than having, the traditional model, you might say, that I think most of us are used to is passwords or shared secrets.
Right.
I have a password and a username to authenticate to a database. I have an API key to authenticate to an API. And what I'm doing effectively is I'm creating separate identities for myself to communicate to all of these different systems. With this instead, I have one identity. It's kind of like my driver's license, and I show that to any other system that needs it. The other system can verify that. It can look at my digital driver's license and it can verify the attributes of it. And if it passes that validity check, and I then say this is I've then decided that you're someone I would like to use my service. I have rights to operate on that service. Then it can then go and do that. And what you've done in doing so is you've you've ameliorated, you've made life much simpler for developers, for one thing, because they don't need to reason anymore about how to create these accounts in APIs and databases. You don't have to reason about how to create the, you don't need to reason about how you get the key material to the application. You don't need to reason too much about how to rotate them. You've grossly simplified a whole set of security concerns that are right now typically done manually with Jira tickets.
So Maya, I just want to quickly touch on kind of your perspective here, because you work on security projects over Google, and you know, and I asked you before, I said, what if you're not using this? And you said basically you have to make your own, right?
Yeah, so I mean, the question you asked was something like, you know, 2 years ago, 3 years ago, what were people doing in the open source? Were people doing it in the open? And to what Andrew was saying, Google created this project. Externally, we call it Application Layer Transport Security, or ALTS. There's a white paper that explains in a lot of detail how it works on our website. And but you're correct. If you wanted to have two applications authenticate to each other, and you're not Google, I've seen probably 2 companies try to build a system like this. And I wouldn't say that they don't work, but they don't necessarily work as well as ALTS works,
right?
Or in the same scale that ALTS works,
right?
And it's painful, right? Like if you have to have 5 or 6 engineers that you're going to dedicate full time to building this thing. Not many people have that kind of resource.
Interesting. Joe Jackson, managing editor, co-host for today's event, is here with the microphone, who's here to get to you if you have a question. But I know, Job, you were at a presentation yesterday on Spiffy. Are there any initial questions you have right now?
Yeah. It still sounds like you have to manage digital certificates, right? Or no? Who's managing the digital certificates?
Sure, I can try that. With certificate issuance, there's a whole set of concerns you need to answer for. You need to figure out if you're using X509 as your certificate spec, there's a huge subset of that spec that you need to decide exactly how you're going to use it. Are you going to use name constraints? What required fields exist on the certificate? How do you actually encode a name and an ID? So part of the challenge is just figuring out how to agree between different clients and certificate issuers what that spec should be. So that's one part of what Spiffy solves for, is by trying to constrain that down to something that's very purpose-driven and much, much more specific. It's a subset of X509. The other thing then you need to do is actually issue these things, generate them, and then distribute them to the workloads that need them. And that's the other piece that Spiffy really tries to automate. So we've tried to incorporate to the best extent that we can best practices around PKI generation and issuance. And the end state is one that, rather than it being a ticket in Jira or ServiceNow to go and create a certificate for this workload, now it's a case of, well, I describe my policy in a central registry, and the API distributes the stuff out to the workload itself.
But if I may, the analog is there. The SPIRE controller is a certificate. The SPIRE controller is pretty much a certificate authority. I'd like to sort of play out the analogs out here. I think that's a really important part of it, because when you think about security, there are certain fundamental concepts, and these continue, and that's a great thing about Spiffy. The SPIRE controller does function like a certificate authority. Spiffy certificates are sort of X509-like certificates. And interestingly, what is known as a node agent is almost like a local certificate authority. So you think of your services, you have nodes, and every node has this node agent. And I want to my point is I want to show the parallels out here, and they're very elegant in my opinion. The node agent runs on every single node, and it's almost like a local CA. And so any service which is running on that particular node makes a call. And that call is the equivalent of a certificate signing request. It really is. A fetch my credential call in Spiffy is the equivalent of submitting a CSR. What is elegant, again, I believe, about Spiffy is the fact that for the first time in the X509 world, and right from the IETF days, it's been a problem, you never had clean, well-defined APIs to say, go get me a certificate. How do you do that? There are a myriad different kinds of ways. Nobody really quite standardized on it. And I think this is quite brilliant that they've actually said, let's actually build the API to say, send a CSR and give it back to me. Send me an authenticated CSR. So there's some very interesting parallels out here. And I compliment the Spiffy team on that, actually.
Excellent.
I'm just going to jump into how Google does this. So ALTS does rely on having an internal CA. It's the ALTS CA. I'm surprised nobody's name dropped service meshes yet, or Istio.
Yeah.
So Google's working on a project called Istio. It's open source as well. You should all be really excited. I'm really excited about Istio. And Istio can use identities such as X5 and answers like Spiffy, and also relies on having an Istio CA for it to work. So you do need to have some sort of PKI.
All right, let's get to some questions.
Yeah.
We got some great.
Sorry.
Hey folks, good morning. This is Prem. So the topic is about securing Kubernetes, but so far what we have talked about is about the workloads, the applications, and the services that you're securing about. But that's not the only item, right? We have 3 layers there. We have the infrastructure layer, we have the Kubernetes layer, and then workloads running on top of them. So most of the things that you're talking about, the certificates, it's targeting the application layer. But what about securing the Kubernetes itself, the API service? Is there any automate to provide certificates out of the box? And how do I secure my Linux kernel, which is running, where the Kubernetes is running on top of it? So all these aspects, if one part of your security is violated, if your operating system is violated, then all of these wouldn't matter at all, right? So any concerns about those topics?
I'm going to jump in. I completely agree with you, right? If I can have a service running in Kubernetes that gets compromised, it doesn't matter if it's authenticated to another service, because it can then make an authenticated call to ask for something that it doesn't actually want to do. So this is part of a broader set of security controls. Specifically in Kubernetes, there's a lot of work being done in the community around better defaults in Kubernetes. To be completely honest, right now it's kind of painful to run a very well-secured Kubernetes cluster. There's a couple of hardening guides. There's one on the Kubernetes IO site. There's one by CoreOS. There's one by Google. Do read them. Things that you've all heard people say before: pod security policy and seccomp and all the things, right?
I second Maya's point that if you have a compromised kernel or a compromised cluster, then you have a whole set of problems that extend well beyond a single workload. But and Spiffy doesn't necessarily aim to solve for those. In fact, it relies on a secure kernel and a secure cluster to a certain extent. But it does provide some primitives to help you limit the blast radius of a compromise. So, for example, the keys generated, to Christian's point, the keys generated are limited to a single node. They never leave that node. Spiffy, by design, encourages short-lived credentials. So there are a few pieces of Spiffy that help you limit the radius, but that said, it's not a substitute for a secure stack below it.
But there are a number of companies in the ecosystem right now that are trying to do things like monitor a kernel to see if the kernel's been compromised. They're designing secure registries so that your images are authenticated as secure. So this is all part of that maturation process, wherein companies are coming into the Kubernetes ecosystem and saying, okay, where are the holes in security? Where are the holes in networking? Where are the holes in monitoring? And there's, interestingly to me, there's some overlap in, for example, people doing monitoring and people doing security, because they're monitoring the health of a kernel or the health of a service and saying, wait, that doesn't look like what I expect. That's not a secure image, for example. So I'm not going to run that image because it's not what I expect. So that is all happening, but that's going to rely to some degree on secure authentication, and secure authentication is going to rely on all that happening at the same time.
Great, Tom. Thanks. Question.
All right, queuing up with lots of questions. Here's the next one.
Thanks. I guess this is for Andreas or Andrew. With Spiffy or SPIRE, how does the node agent know which identity to give to a pod?
I'll try and field that one. When you have there's typically 2 levels of attestation that is performed by SPIRE on a workload, and so there's the node agent attestation itself, which is verifying the kernel that the node is running on, but then you also need to verify the workload itself, the process itself. So the workload API is exposed, and I'm getting into minutiae here, as a Unix domain socket. Or at least on Unix, it's exposed as a Unix domain socket. And so when the workload calls that, the node agent is able to retrieve metadata from the kernel about the process, things like PID and UID and so forth. In the case of Kubernetes, you have a kubelet running on the same local node, the node agent has a plugin which will talk to the kubelet and retrieve kubelet metadata. It'll basically ask, I have a process, it has this PID. Is this something that you've scheduled on this node? Do you know about it? If you do, can you give me the pod spec and other metadata about it? All that ties back into an attestation policy that you've defined in the SPIRE server that says this identity should only be issued A, to something running on this node, and then B, something that matches this particular pod spec. That might be a namespace or label or something else.
Andreas has been listening to this very patiently, and I'm curious on your perspective here, because you're working with customers, I know. And what are some of the kind of thoughts you have as you're hearing these questions and some of the discussion here?
Yeah, I think the main point is that SPIRE solves the bootstrap problem and provides a simple way to establish identities. And this is really a big pain point in enterprise installations because simply of the scale of the problem. In the classic world, you have JE clusters or mainframes or whatever, and your own data centers. And everything within it is secure by default, or at least it's not exposed to the outside, so the policies won't be as strict. And now we've decomposed the applications, decomposed the clusters, have hundreds of microservices, and that's really an issue if you have any kind of scale complexity-wise.
Right, right. The complexity is enough as it is, right?
Yeah.
Yeah.
And the other thing is if a solution isn't simple to use for the application developers, they won't use it. So for instance,
Yeah.
we did plain TLS with X509 certificates, manually managed some steps to automate this, but it's hard and errors happen.
Great. Questions?
So my question is related to the availability problem. I guess the obvious advantage of a shared secret is that two services can communicate without anyone or any other service being required. If you've got a centralized authentication service, doesn't that become a critical point of failure for your service as a whole?
I'll try to field that. So absolutely. With Spiffy and SPIRE, you have the authentication token that we provide as a certificate. The one way you can mitigate against or mitigate against availability concerns is to have a longer-lived certificate. So by default, I think SPIRE certificates live for about an hour, which means you've got about half an hour, usually, if you start halfway through that TTL to retrieve your next token. So as long as your outage window is shorter than that, then you should be okay. But long story short is there's a trade-off between how long-lived you want these certificates to be and the availability that you see or the availability risk that you want to place on your underlying infrastructure.
I'll just point out for ALTS, which is Google's internal version, yes, it's completely a critical piece of infrastructure. And you could have a continuation, two services keep talking to each other if they've already talked to each other using a long-lived ticket, but you wouldn't be able to generate any new communications. And even that long-lived ticket only lasts on the order of minutes.
Question?
Morning. Where and how do I get started with this?
That's definitely for me.
Spiffy.org?
Yeah. Spiffy.io is the best place to start, and or GitHub/Spiffy.
The next question.
So my question is Spiffy only for single cluster? My concern is that Kubernetes is insecure by default, and while I'm trying to harden it, I'm still not sure that it's secure, so I have multiple clusters, or maybe I have some workloads running outside of the cluster, and I want still have all this Spiffy magic running for all the thing and secure everything.
So maybe we could get Krishna. I mean, must be a concern you hear about, isn't it?
But I think the higher order bit here is once you deploy a reasonable, let's call it a CA infrastructure in place, you're going to actually ensure that, you said something, you said insecure by default. Was that what you just said when you said?
Yeah, Kubernetes cluster is basically insecure by
and
default.
I kind of I totally agree with you on that. And I was actually reading somewhere about somebody saying self-signed certificates for their etcd clusters. And I'm like, wow, that starts with basically being insecure. I think it's important. You have to be secure by design and secure by default. So if you want this level of security, we are going to actually have to ensure that we have a PKI system in place. We're going to have to make sure that our Kubernetes endpoints have certificates. We're going to ensure that these certificates are rotated appropriately. We're going to ensure, we have to ensure that you have revocation mechanisms in place. And it's been difficult. This is why we're here again, right? Because it's constantly this arc of re-innovation, right? And we're at this point where perhaps we actually will now have the APIs and we'll have the simplicity of infrastructure to make this thing seamless. And that's the opportunity right now. And I think, why is this so important, right? Security always seems to be an afterthought. If you look at AWS services, you'll find out that IAM came right at the end. Everybody sort of says, well, this is something I don't want to deal with, and I do at the end. But it's all about timing. And if you actually build on the system...
So is this the end here for Kubernetes right here? Then is this the end?
No, I think it's just the beginning, right? That's what I would say, right? So yes, you must actually, I think it's going to be an imperative for all of us. And your reputation of your infrastructure, the reputation of companies, and by extension, open source projects, you get better reputations if basically you have secure infrastructure. So I think it's an imperative. It's something we all have to do.
I think you're ultimately asking a question about multi-tenancy, which is I have two things, and one of them is more trusted than another thing. Can I run them in the same cluster? Or can I use Spiffy to have them in different clusters and have them talk to each other? Multi-tenancy is an interesting question. So if you want isolation, historically we rely on hypervisor isolation. You'd put each thing on its own node. Now in Kubernetes, you probably want to put them each in different clusters. Just from a pure management point of view, it ends up being slightly easier. Especially if you're running like a SaaS application, you might have one customer's data in one cluster, a different customer's data in another cluster. I know customers running, this cluster is PCI compliant, this one's not. This one is only in the US, and this one's only in Europe, whatever it happens to be, right? So if you're talking within a cluster, right, you can use network policy in Kubernetes to have things talk to each other and control that. Remember that the network policy is open by default, so go set one. And then if you're going to talk cluster to cluster, then something like Istio using Spiffy makes a lot of sense.
Just to expand on that a little, and I won't pretend to be a Kubernetes expert, but when I've talked to folks, I've seen all sorts of different ways of describing what a service should be. Some people will use the service primitive in Kubernetes, some people use namespaces, some people use entirely separate clusters because they really want guaranteed isolation. Yeah, Spiffy has a single identity authority can work with multiple clusters in parallel.
So, but one last thing, though. I don't want what Krishna said before. I don't want that to kind of just go by, which was, we don't necessarily design for security when we design applications. I mean, often what happens when you see application development happening is you'll sit there and your developers will write all their code, you'll test all their code, and we'll go through all this, and then you hit a security review. Somebody decides they're going to do a security audit before you can, go live, right? So, your release manager is sitting there going, so let's check that box off. And then, of course, security guys all go, nope, doesn't work that way, right? So I think it's really important to say, no matter how you're doing it, no matter what you're doing it, security's got to be part of it. I'm starting to really come around to that. I mean, a lot of these terms kind of get ugly when you unpeel them, but we talk about DevOps, and now we're starting to say DevSecOps. But I think that's awful because, and the reason I think it's awful is because it takes security outside development. It suggests it's not part of the development.
Well, it should be.
No, security's got to be baked into development.
But that's the shift right now, right? That's the shift left, right, that we're seeing.
The term that I've heard used, people don't seem to like DevSecOps. The term I've heard used is continuous security. The idea being I'm always adding security.
Yeah.
Continuous security.
Right.
All right.
All right, I got another question here.
It's me again, so usually I'm very unlucky, so trying my luck to go to my charging more tickets. Anyway, so this has been my problem. I guess this is the problem for all folks here too. Open source is really good. We have enormous choice of components for the same purpose. For example, storage, we have OpenBA Storage OS, or whatever it is, name it. We have around 10 or 15 ways of doing it, and similarly for network. And for security, we are seeing the same thing happening. Okay, so Istio says MTLS, KubeLego says I can get your certificates automatically, and yesterday I learned about this new project called Spiffy and SPIRE. So as an integrator, how do I make my choices? So how do I see the pro and cons of each of these? And how Spiffy and SPIRE, how are you planning to sell your component in this race? So.
Do you want to try this, Andreas? Because you guys spent quite a bit of time evaluating different options before you looked at Spiffy, I believe.
Yeah, and I think the really cool thing about Spiffy and Spire is that the bootstrap process is just automatic. With every other solution, secret store or whatever, I have to take care.
Istio says the same thing, right? With MTLS, you get.
Yeah, Istio also uses Spiffy IDs.
But
so
how do you get how do you
it's
get
a basic
your,
idea.
for Istio, how do you get your MTLS, your certificates? For MTLS you need certs, right? And so Spiffy is going to give you those certs. So, yeah.
So I think all of these have to work together, right? It's not like you're going to use Istio and not use Spiffy. You're probably going to use them together. You're going to use Kubernetes, I hope, because you're in this room today. You're using a bunch of other things, right? It's not about picking one over the other. It's actually our duty as contributors to make them all work really well together. And if you're trying to make these work together and it's not working, there's something wrong. Right? We've missed something as a community as to how to make this easy for you to use. There are a couple projects that don't exist, where right now I'd love to see people start to build new things. One is an open source CA that actually works. I would love that project.
They don't work now?
Name an open source CA. There's CFSSL and HashiCorp called PKI backend. I don't know of any other option out there right now. If you have something better, please open source it.
Anyone using
Right.
anything else out there? Okay.
Yeah, I would love a policy language that is actually fairly universal across all my services. Right? I know OPA is in the sandbox right
Right.
now. I haven't personally played with it. I can't, recommend it or not recommend it or anything. But
Right.
that would be amazing to have that kind of stuff. So there's some key components that we're going to need in open source across all of these things anyways. And if you're trying to plug Istio into Kubernetes and it's not working, we failed. And you need to, shout out so we can go fix it.
And to Mayor's point, I mean, all this stuff does need to play together, and I think, it can be a little hard to see it at this point. I feel like where we are with security APIs is in some ways is kind of where we were with container runtimes 2 years ago. There's a lot of projects that are working on a lot of overlapping areas, but we're starting to see some of the same kind of principled layering that's happened in container runtimes happening in security.
What are
too.
those principal layers that you're seeing?
Well, I'll give you my personal perspective, which is that the lowest layer is identity.
Right.
Once you have a robust identity platform, which Spiffy is very specific about, it doesn't reason about transport security, it doesn't reason about authorization. It's just about providing that identity. But once you have that as a robust layer, then you're very well set to start building higher value other layers on top of that.
If I could add to that, that's another really elegant thing about Spiffy. It focuses on authentication, if I'm right. It's just authentication. And if you look at the other protocols that went about there, like, SOAP standards with WS security trying to inject claims, authorization claims into it, it sort of got over and over and over complicated, right? And here you have an entity which says, I do authentication, I will give you an identity, right? And that identity will be a form of an X509 certificate, but I will give you the ability to roll that out smoothly, revoke it, and sort of deploy it at scale. And I think whether it's your Kubernetes API endpoint, whether it's basically your application services, whether it's your it's services, if you're trying to run Istio and you need between two services you need to have MTLS, all of them you have a common infrastructure to request a certificate, revoke the certificate, renew the certificate. And it starts there. And and again, as I said, for me the aha moment came when it was easy to get a certificate. And you've never really had that ability to seamlessly sort of request it in a programmatic fashion. I think that's one of the elegant things about Spiffy. Many projects try to do too many things too quickly. Here's one which is focusing on a single problem and trying to do it right. So that's my pitch, in some sense.
And identity is, and Krishna, you've spent a lot of time working on this, so you can probably speak to it better than I can, but identity is even though it's a small part of an overall security story, it's actually a really complex problem when you get into the weeds.
I think you think about identity in other technology markets that we're not a part of, right? Where like it's just the username and password mechanism has been used so universally, for identity, and it's obviously creating all kinds of issues. That to me is like the interesting aspect of Kubernetes here, is like we're looking more at roles, right? And like what is that role kind of the system itself, and what does the different components of the system play?
All right, we have another question.
Good morning, Tony Thijs, Dutch IT channel Open Marketing TV. I have a question for Maya about complementary things about Istio, like traffic management, observability, policy enforcement, and secure identity. How does that complement Spiffy?
Yeah, I'll do my best to answer this question, but Dan, who's sitting at that table right there, is actually the PM for Istio, and
All right.
would love you to come talk to him
Come on, Dan.
afterwards.
No, actually, we'll come to you, but, you know.
Okay.
Yeah,
Sounds good. He's the right guy.
Oh, we'll get back to you.
I'll give a couple answers.
He's going to.
The first answer is that the important thing about Istio is that we do depend heavily and rely on this idea of service identity. So that when you're making policy decisions and you're saying, is that service allowed to call that service, or how often can that service call that service, you're doing that with confidence. Authorization is meaningless without strong authentication. And what we get through Spiffy and SPIRE is strong authentication. And going back just a minute, I didn't want to interrupt because you guys are doing a great job up there. The thing that's important about getting this right and all these projects working together is that you want to solve this problem once, and you want to solve it in such a way that it becomes part of your infrastructure, and that individual developers are never having to solve this problem. So that if you're a developer and you're deploying a service into your Kubernetes cluster, you do that without thinking about security, knowing that you've got, whatever, you've got Kubernetes, you've got secure containers, you've got Spiffy, you've got Istio, and that as a developer, all of the security will be taken care of. And once you've done that, and you've got a true secured by default, your developers are more productive because they're never having to think about these security problems. And I think that's the real goal of getting this stuff all working together, is so that then your developer never has to think about it at all.
What about traffic monitoring?
What's that?
Traffic monitoring.
Well, I would say that the thing about traffic monitoring is it is all, again, tied to identity. The thing that Istio does is it gives you a good picture of which service is calling which service. And when I say which service, what do I mean? I mean a secure identity. I know which service that is. That is all rooted in identity. It's not a header that I can spoof.
Right.
It's not an IP address. I know who is calling whom because of that identity token, and that identity token came from that infrastructure.
You're taking a difficult job out of the hands of developers.
Yep. Right. Yeah. It's all of this is just building more and more and more functionality into the infrastructure, so your developers don't have to write that stuff. Because every one of these problems, if you don't do it, your developers do, and they do it over and over and over again, and each team implements it over and over and over again.
On its own way.
Right. Right.
Okay.
Questions?
So this is just authentication, not authorization, right? Just to be clear. Yeah. Because that authorization.
So as Maya said, there are efforts. Istio also has a way to invoke authorization policies, and OPA is one of the ways that can be done. OPA is a policy language for describing who can call whom, or even more fine-grained stuff. Can you read this particular bucket? But again, authorization can only happen once you have strong authentication. So all of these things, all of the monitoring, all of the traffic decisions, all of the security decisions have to be rooted in a strong authentication. And that's why we're big believers in Spiffy and SPIRE.
And while we're asking, while all questions are getting answered and people are asking questions, please raise your hand if you don't have a ticket yet, if you didn't get a ticket coming in, so we can expedite it at the end. Okay, great. So who has a question here? Then we have another question over here.
We got one over here.
Okay.
I don't know what kind of algorithm you're actually using in Spiffy, but writing distributed applications is a hard problem, and writing distributed security applications is even harder. So I know that most big cloud providers are actually using functional specification, like Google, Amazon, Microsoft, very deeply into that, because even the best engineers do serious errors when writing distributed applications. Is anybody in this community actually thinking about that, about the functional specification of the stuff you're doing here?
So yeah, there's the short answer is there's a pretty significant body of work. Spiffy formally is actually a specification. SPIRE is the software that implements that. And while there's a huge overlap, as you might imagine, between the folks who are implementing the specification or designing the specification versus implementing the software, there is a distinct coupling there, and it's partly for that reason. The other thing that the community is doing is, and the CNCF has been really helpful with this, is sponsoring a security review of the project. So we have Justin Kapos from NYU, who's also been very involved in the Tough project, has been helping steer the project through defining formal threat models and building out the building out the capability in the gap analysis. And the goal of that is twofold. One is to, where there are issues in the project, making sure that we identify those as quickly as possible. And then also give good guidance for people who are implementing this to make sure, as security engineers, they understand well what problems Spiffy is going to solve for them and what problems it's not.
You actually meant formal specification. I mean, actually prove that what you do is right.
Mathematically.
Yeah.
Questions?
So no, there hasn't been formal verification of these protocols, but a lot of protocols that are so formal verification. Sorry to not scare anyone, is like mathematical proofs that the thing is not breakable, right? And I'm not talking about this thing is hard to factor, like an integer is really hard to factor, and I can't break this crypto. I mean, like you can prove that you can't circumvent this protocol. So no, there's no formal verification of this, but there also isn't formal verification for basically anything that we use today. So it would be cool to have it. But I wouldn't put it at the top of my priority list.
In terms of crypto as well, it's worth pointing out that Spiffy really leans on X509 to a large extent.
Right.
So it's again is not a substitute for formal proof, but it also is it's not by design is very much not trying to reinvent the wheel there in terms of algorithms or signature formats.
If I may add, the key part in some sense is how do you issue an authenticated, how do you issue, the workload API from what I understand is a workload issuing a CSR request. It's an authenticated, in some sense, it's an authenticated CSR, a certificate signing request. It says, I am so-and-so. At some point, it has to, it's the notion of workload attesters are all about saying, I am so-and-so, issue me a certificate right now. And the node agent has to sort of verify that and say, yes, I trust that this is who you are in some sense, and here's your corresponding certificate. So that really is, for me, that's the heart of the workload API. So it's like the rest of the crypto is all X509, as Andrew's saying.
We have time for about one or two more questions.
Hello. My question is regarding adoption into bigger companies that have different security departments. So when using Kubernetes, you're forced to use a lot of these tools. What does the community do in order to prove that these tools are secure and make it clear to those departments that they are secure? Why should I use your product? How do I prove to them it's secure? I mean, the argument that it's open source and that the code is readable isn't really valid anymore since there are so many lines of code to read and understand. So what does the community do in this perspective?
So I'll jump in about Kubernetes specifically. So there's obviously a Kubernetes SIGAuth, which is not aptly named, but is the security team, the security group that looks at Kubernetes features. They don't review everything from a security point of view, but they definitely have the incentive to build in new security features. There's also this Kubernetes product security team, which responds to any vulnerabilities. If you find a vulnerability, please responsibly report it to that team, and they will fix it as part of an upcoming patch. At Google, we have probably about 10 people now who focus entirely on Kubernetes security. So we have people whose entire job it is to help make Kubernetes more secure. And I hope that's not just us who's doing that. I think there's quite a few people at CoreOS and at Microsoft and other companies doing the same thing. But there hasn't been a full formal security review of Kubernetes as far as I know. We have discussed in the community starting a bug bounty that isn't yet formalized, but still under discussion. So we do want people to take a look at this and play with it.
But there is two things to keep in mind here, though. Number one, which is that because it's open source, maybe you can't go through every line of code in there, but somebody's doing it. There's always going to be somebody out there looking through it, whether it's at Google or inside of a company. And the other is, how much trust do you have in your vendors when they sell you these products? We very rarely, as analysts, will say, go ahead and just use open source out of the box, unless you have a team like Google has, unless you have lots and lots of people to work on it. So you're probably buying it from some trusted vendor, and you have to assume that they're doing their job when it comes to this. If they're not, that's part of your evaluation. To go back to the question that was asked earlier, isn't that part of your evaluation? How much work have they done to make this secure, to authenticate the security of it?
This is also some of the value of having, again, kind of principled layers of security. It doesn't in itself solve the problem, but it does mean that you have tightly bounded concerns that you can start to factor in. So you can say, well, if I trust at least some parts of this well, I have a much better understanding of where my potential vulnerabilities might lie.
Let me ask one last question here.
Thank you. So where is the boundary of Spiffy's concerns? Is it at the edge of the cluster, or could you potentially use Spiffy with the mobile apps?
That's a great question. And to paraphrase it, I would say, should Spiffy IDs just be issued to, we've been talking about IDs in the context of workloads running on servers somewhere, but could you also talk about workloads running on mobile devices or on IoT? And the short answer is, I don't think, we've had a lot of general interest from folks in this domain. For mobile attestation is particularly interesting. It's something that we've had a lot of interest in, but I wouldn't say we have yet gone down the path of identifying exactly what solutions would look like. So in a general sense, yes, and the beauty of the framework is it's extremely extensible, so it's not hard to imagine cases where you could do that. But I wouldn't say yet we have.
That's another door to open.
Exactly. Which is one of the nice things about early open source projects,
right.
Is there's room to grow.
Well, let's give a big hand to the panelists here. And let's give a big hand to VMware for sponsoring the Pancake Breakfast. Thank you so much. It's been a great discussion, and now comes the drawing. Oh. Okay. All right. All right. So, Krishna, why don't you draw? Or who's drawing?
Krishna.
All right.
You gotta mix them up.
Do I mix them up?
Yeah.
All right. I got one. Do I call it out?
Yeah.
All right. I'll put the microphone closed this time. 900732. 900732.
Does someone have it? Yeah. All right. A winner. Thank you, everyone. Enjoy the show. Enjoy the keynotes. Come by and visit the podcast booth if you want to chat. We're there all day. Bye-bye. Thanks to VMware for sponsoring the new Stack Pancake Breakfast stop in Copenhagen for Kubecon plus CloudNativeCon 2018. Learn more about the open source story VMware is developing at vmware.com. Listen to more episodes of the New Stack Makers at thenewstack.io/podcast. Please rate and review us on iTunes, like us on YouTube, and follow us on SoundCloud. Thanks for listening, and see you next time.